everybody. Happy Saturday. Thank you to YWCA of Chicago. Thank you, Mr. Porter, for hosting this an immense social media presence, and really happy to be here on a Saturday. Dr. Moore and I are going to try to navigate this as much as possible. Principal Redmond, thank you for setting the technical details up on this. And Ms. Johnson, thank you for being our host and moderator. I think how myself and Dr. Moore are going to approach this, think of this like a Sunday football game. I'm going to be play-by-play, and Dr. Moore, as the money guy, he's going to be like Tony Romo and do the color commentary. And so we're going to dive right in. Can everybody see my screen? Excellent. All right. Really simple overview. And I think, like Ms. Johnson said, we may stop from time to time to sort of take questions depending on how the flow goes. And we'll just kind of go from there. But I think it's important to understand the vaccine overview and development. How are we going to distribute this thing, right? And what are the issues that we've had with vaccine distribution to date? What are the concerns? Right? What are the concerns with this vaccine in terms of safety, in terms of the conspiracy theories that you may have heard, in terms of the vaccine hesitancy that exists in our communities, and how are we going to get around that? And I think it's important at the end, myself and Dr. Moore will really say, hey, shot or no shot? Have we gotten the shot? Do we plan to get the shot? Do we plan that our family members get the shot? And so we'll kind of go from there. Hopefully, you have seen this. This is a pictorial representation of the coronavirus, called corona because of the crown, the spikes that are on the edge of it. And this is really what has dominated our lives and our news and everything that we've done essentially since December of 2019, since it was first reported out of the Wuhan province. I'm going to give a timeline, and then as I go on, because Dr. Moore is the expert in this space, I'll sort of let him speak. But I think it's important to sort of recap 2020 and really remember where we were and where we've gone. It's been an immense and amazing year in terms of the pace of science. And so it was, again, mentioned that November, December, Wuhan province, we started getting our first cases in the United States officially in March. Some of the RNA have shown that it was probably existing back in February. But by the time we got to April and May, we were already talking about masking. We were talking about, wow, this can affect the heart, the blood, the kidneys. There was the whole remdesivir conversation, right? And Gilead came out with remdesivir as a medication that could not cure COVID, but could change the duration that somebody stayed in the hospital, right? So it blunted the effect, but not necessarily changed the effect on mortality. We went through the whole hydroxychloroquine, I'll just kind of call it debacle. I'll be really blunt about it. The whole hydroxychloroquine debacle. We found out that steroids, right, one of the cheapest medications that we still have in existence to date, still the only medication randomized controlled trial with enough people to actually say this has some effect that can actually change mortality, can actually help people survive that have severe COVID. June, July, we started hearing about, oh, wow, so this might last longer than just an acute illness. I might have this for months or years, the so-called long COVID or chronic COVID syndrome. We'll talk about that. And then the exciting stuff really started to happen, right? So the United States and Europe, China, Russia as well started to get into that vaccine space. And by November, Pfizer, BioNTech, and Moderna revealed that their vaccines had on average 95% efficacy, and now we're getting vaccines in arms. And so 2020 has really been the year of COVID, but not just that, the year of science. Dr. Moore, what are your thoughts?
Well, I think you opened it up perfectly. This was a situation where, we started back in late February. My lab got tapped to participate in this project, and so to go from early January, February, people starting to talk about it. One case pops up on the West Coast over in Washington State, and next thing you know, now where we are here. You walk outside, everybody you see, at least in my area, I'm in Maryland, in the Maryland, DC area, you see everybody with a mask. And so you see how that situation grew out of control and was just completely, it was fumbled from the beginning, largely because of the lack of leadership and telling people to mask. And masking is and does work. So I want to make that clear. Masking is and does work. But we also have to get vaccinated. So, but you open it up exactly right. And I think the timeline is perfect. And so to go from this virus being essentially being a thought or a conversation to there being a vaccine available, if anything else, there should be a situation where people are knocking the door down trying to get vaccinated, because we know that it's real. We know that it is. We know that the cost of not taking it serious can be either severe illness or, in some cases, in many cases, death. So I completely agree with you. So I'm gonna let you go ahead, and I like this play by play. I like this rhythm right here. So I'm gonna put my headset back on and jump back in when you hand it back to me.
Absolutely, I appreciate it, my friend.
Yeah.
And so, kind of going forward, right, I need people to also understand, right, and this is sort of just talk to what Dr. Moore referred, which is people have to understand that in as much as this started in February, this is a worldwide effort, and there's actually some background behind it. So I think that's important. And so if you look at this global map of what were the countries that were looking to do vaccine, right? There's a lot of places, the United States, obviously, Europe, China, Russia, Australia. By the time we got to October of last year, these were really the real candidates, right? And actually, these are the ones where we say, hey, this may actually be working. I think it's important just to take a look and see where we are right now. So 36 in phase 1, 25 in phase 2, 20 in phase 3, authorized 3, approved for full use, and candidates drop off the list. And so again, I'll send this out through Ms. Johnson and Principal Redmond so that you can look at it. But again, a host of data that's been accumulated over hundreds of trials. Sometimes it works, sometimes it doesn't. We've actually been blessed in the United States that our first 2 candidates were approximately 95% efficacy. Interestingly enough, that is probably going to create some downstream problems when we start to talk about some of the other candidates, right? But again, sometimes it's better to be lucky than good, but kind of take it from there.
Can I add some perspective right there?
Absolutely.
All right. So you mentioned a good point. So the first 2 vaccines that came out, of course, the Moderna vaccine, which I was involved with, and then the Pfizer vaccine, 95% and 94% or 95% roughly efficacious. And so then you have other companies that are going to be coming out, and some of them are in the 60s, some of them in the 70s. So I want to put that in perspective. My background is actually influenza research. So before I actually took this position, I was a PhD student in the influenza lab, and we did vaccine development in that capacity. Some of the most effective flu vaccines that you have taken, potentially have taken in the past, were only 50 or 60% effective. And so, but, people were taking them and they were fairly protective, 60% efficacy. I think 50% efficacy is what it needs to get FDA approval. So 60% efficacy is really good. So now you have something shoot up to 95%. Anything that comes below that is now going to be looked at with a questioning glance. And so, but what you have to do is, and I'm sure Dr. Alozzi is going to mention this later, but you have to pay attention to the certain numbers, not just the number 50 or 60, but the number that's associated with protection against severe disease, hospitalization, and death.
Absolutely. I appreciate it.
Dr. Alozzi, back to you.
Yep. Thank you, sir. And so I think, as Dr. Moore sort of said too, and I think this is really important for people to understand, when you think about the research around vaccines, we're new because it's an mRNA vaccine, but this has been going on for a while, right? And I think it's important for people to understand that the family that COVID-19 is in, the coronavirus family, we knew about this back in 2002 with SARS. We also knew about it in 2012 with MERS. That laid the foundation for scientists across the world, including Dr. Moore's lab, to have an inclination and sort of a back door through which they could get to this quickly. And so that's where that speed comes in. People will say, well, I don't really understand, right? I mean, back before, we've had all these other diseases and we've never had a vaccine this quickly. And you're absolutely right. We haven't had it because guess what? We didn't have the same technology. 20 years ago, we didn't have an iPhone 12. It doesn't mean that you don't still have a phone. You still have a phone. 20 years ago, Teslas didn't exist. And yet people get in them and drive all over the place, right? And so I think we have to understand that as a human race, we get better. And this is a good thing. The other thing that this is also driven by, and taking politics aside, the power of Operation Warp Speed was immense. And so these are some of the companies and some of the monies that they received by Operation Warp Speed. And whether it's J&J, they got $1 billion, AstraZeneca 1.2, Moderna 1.53, Novavax 1.6. That money, that federal stimulus that went into these companies to get through a global pandemic was essential, on top of the brilliant minds of people like Dr. Moore and others, to get to where we needed to be. It also allowed these companies to do parallel testing as opposed to sequential. What usually happens is that you run a trial and you're like, I think I need $500 million. Who's going to give me $500 million? And then you wait 5 years for somebody to give you $500 million. Then you go to phase two. Then you go to phase three, looking for another $500 million. In this case, once preliminary data show that, hey, this might work, they stacked it. And so they could run trials at the same time, understanding that the money was available. And so again, it's not a conspiracy, it's science and it's money. At the end of the day, it's all about money. I tell my students all the time, if you want to find out the reality of something, figure out where the dollars came from. And again, I think that's important for people to understand.
Exactly. And so, can I add a point there? All right. And so on that, to acknowledge the obvious thing, I mean, my lab and the NIH in general were recipients of Operation Warp Speed money. I do think that probably was a poor choice in name. Just to be honest, I mean, you could have named it anything else, Operation Kill Virus, anything, but Operation Warp Speed, I think that was just a poor choice in name. But as you were explaining, it is a situation where somebody wrote a check and said, hey, go for it. And essentially, we're in a pandemic. So yeah, there are vaccines that in the past that have taken many years to develop, but most of those vaccines were not developed in the midst of a pandemic. I use the example of, everybody on this call, if you have a house or an apartment or whatever you live in, imagine if you wanted to build your own house. Imagine you building your own house. You have the land, but you have to buy all the supplies. You build it yourself. Nobody else helps you. How long do you think it takes to build that house? It would take you would probably have to live in it for years before it's complete. Now, imagine if somebody in your neighborhood, a neighbor said, you know what, we want you in this neighborhood so bad. I'm going to cover all the fees for you to build this house. And imagine if all the neighbors that currently live there said, hey, you know what, we're all going to come. We're in the middle of a pandemic. We're going to come and help you build this house. How long do you think it takes to build that house? The house is now built in months compared to years. So that is essentially what happens here. All hands on deck, and then the money is there. So as Dr. Alozie said, these trials, some of the trials were run in parallel, but they were not rushed and they were done in the correct way. But there was nothing else to do because there was nothing more important than the pandemic that we were in the middle of and that we are in the middle of. All right.
Absolutely, I appreciate that. And so to give people sort of a timeline of where we are or where we've come from, you can see the sort of sequential approach, right? So in December, fast forward to October, the enrollment of over 74,000 people, and now we're actually getting shots in arms. And I think that's the exciting thing. Dr. Moore, I'm going to let you sort of walk through how the vaccine actually works, because I know there's a lot of people that ask me this all the time. And I try in my very sort of small infectious disease way to drive it, but I'm going to let a scientist do
that. Yeah. So I'm actually going to use, I'm going to try to use relatable examples to make it understood. So imagine that so we know, as Dr. Alozie showed, and as this illustration shows, you see the spike proteins, the spikes that are on the outside of this virus particle. Now, those spikes, imagine those spikes are like a key. The spikes are keys, and you have locks that are just hanging out on your cells. All the cells in your body, certain cells in your body have a lock. This spike has a key. If in a normal circumstance, this virus gets into your body, makes contact with cells in your lung, it docks, just like a plane landing on a tarmac. It lands on the cell. And so the minute those spikes make contact with the lock or the receptors that are on your cell, it opens and the virus is allowed to go into the cell and it's allowed to now take over your cell. This virus hijacks your cell. It tells your cells, hey, look, I'm running this right now. I want you to do anything else but make me. So it starts to give instructions on how to make more proteins to build new viruses that essentially will bud off that cell and go and infect other cells in your body. So that's how the virus works. So now what we have done, we've taken that a similar method, but imagine now those spikes. Those spikes, we said they're keys. So now we have taken the information that we know how to make a key, and we give that to your cells in your arm. You get an injection in your arm, and so those muscle cells, they have all the same stuff that all the cells in the other parts of your body have. That instruction goes into the cell, and in the cell there's a structure called a ribosome. The ribosome is going to essentially translate what you are asking it to make. It makes those spike proteins. It doesn't have virus in it. It doesn't, the spike protein itself can't do anything to you, but it takes that spike protein and it makes it. And now you have something that the body can use to identify the virus when it comes into contact. So your body makes the spike protein. The spike protein goes to the surface of those cells, and immune cells in your body say, "Hey, that's not supposed to be in here." So then they go and report back to their buddy, say, "Hey, this guy has a spike protein. It's not supposed to be in here. I think we need to get ready just in case somebody comes around that looks like this." So now those guys and those buddies are antibodies that you see here that look like little Ys. Now what happens is the next time, now that you have an antibody response following the vaccine, the next time that your body is exposed to the virus comes in, it's like, oh, I'm getting ready to land on a cell. I have my keys, you have your locks. But what happens is those antibodies have been waiting. The B cells in your body, they produce antibodies, they're waiting. They release all these antibodies. Those antibodies physically inhibit, they coat these viral particles. They block the key. Imagine you're trying to put your key in the door and get in your house and somebody keeps putting their hand over the lock. That's exactly what goes on here. And so now the virus can't dock on the cells. It can't be taken in, and therefore it can't get inside your cells to replicate. And so that's where the technology comes in. We give the instruction to help the body recognize the keys or the spikes without giving you the virus. And that's specifically for the mRNA vaccines.
Absolutely. And as Dr. Moore sort of said, and I found this cartoon on Twitter a couple of weeks back, it's probably longer than a couple, but I mean, literally, like you said, it's like random loose MRA lying around in your deltoid, right? Post shot, nobody says nothing. And the ribosome that he spoke to says, hey, let me go ahead and transcribe this. And then the macrophage is like, hey, yo, check out this cool spike protein I found. And the T cell's like, dog, what's that? Get rid of that. Where's Bob? Bob's the B cell. Bob's like, yep. Like, if that ever shows up here again, don't let it in. And Bob's like, yes, sir, or yes, ma'am, as the case may be. And it's a simplistic way, right, to sort of break down what Dr. Moore said. But again, that's essentially how these vaccines work. And again, sort of simplified, they use the sequence of the spike protein to synthesize an mRNA blueprint. It goes into the body and it tells your body to create the protein. It does not produce the virus. So you cannot get infected by the vaccine. Critically important. The protein signals Bob, your B cell, and T cells, and natural killer cells, and a whole host of other cells that we actually don't talk about enough to activate to fight against future infection. And then your body gets rid of the mRNA. And so for those of you who are younger, who have social media, mRNA vaccine is like Snapchat. Right? It goes into your body, it's a quick picture, and it's gone. You can't have it anymore. You can't see it anymore. Your body remembers it. And the next time that picture shows up again, it's like, oh, I know how to deal with this. And that's essentially how vaccines work. Dr. Moore?
Yeah. So one more point about that. mRNA vaccines, even though up until this point, there were no licensed vaccines that were mRNA, that was actually, that was in part due to the fact that mRNA, if you give it just by itself, uncoated, you give it to the body would degrade it. So that's why it's one of the safest vaccine platforms you can use, point blank across the board. But it was having issues being effective because the body would just destroy it. That just goes to show you how sensitive and how sensitive it is to being in the body. But what happened is they got very smart and said, you know what, we have to be able to protect this mRNA until it can get into the cell. So then that's when they wrapped it in lipid. So lipid or fat, they wrap it in these nanoparticles. And now, if you imagine you're you're washing dishes and you have soap on your hands, you can pick up another bubble when you have soap on your hands because your hand is coated in the same material. But if you had a dry hand touching a bubble, it'll pop. That's the same the same principle here. You wrap it in lipid, it protects it, it gets into the cell, then it can do its job. But before that, and so that's why these vaccines are so unique. So that's the part that I want to make sure that people understand. The mRNA vaccines are safe. They've just figured out recently how to get them inside the cell more reliably, and now they work very well. And that's why you have 90 and 95% efficacy versus some of the lower numbers that we've had for traditional vaccines.
Absolutely. All right. So we're going to take a step further now and talk about the actual vaccines that exist, right? So we'll just tee it up almost in sequential order. So the Pfizer, BioNTech, their partners, an American company and a German company specifically. And this is sort of an overview. I'm not going to make this data heavy. There's some that want to see the data. And so again, we'll share this with the YWCA so in Chicago so that they can get it to people. But I think the important thing here is this graph. If you haven't seen this graph, it's been everywhere, right? Whether it's on presentations like this, CNN, Fox News, online. This is, I think, one of the graphs of 2020, right? Even if you've never done a clinical trial before and somebody tells you, do these two drugs act the same? This line tells you absolutely not. Something's going on with line blue that's different than line red.
Mm-hmm.
The important thing here is that the red line is the vaccine group. And up at the top, you can actually see that the lines prior, so everybody got vaccine on day 0, and they start to break apart at day 11 or 12. So there's the belief that there is some protection provided initially around day 11 or 12, and then you get that second shot either 21 days or 28 days, depending on which of the vaccination brands you're receiving, but that provides the protection. And it's really important for people to understand that. I think this graph does a great job of also explaining that in the vaccine group, which is on the left side of your screen, well, it's on my left, there are 8 people that got COVID, 1 severely ill. And in the placebo group, 162 got COVID and 9 severely ill. That's the 95% efficacy. And that's what we continue to see in other population studies. And I think Israel has really shown the best efficacy of how vaccine can start to change the tenor of COVID in a country. They're at 30% of their country having COVID, and they're already seeing a remarkable decrease in cases and hospitalizations and potentially deaths. So I think all of those are yet to be seen. People always say, well, doc, if I get this vaccine, what's going to happen to me, man? I hear people get sick and they get hospitalized by the vaccine. I think the first answer is no, that's not how that works. But I think more importantly, let's look at the data, right? We always knew that after the second dose, 73% of people were going to have pain. At least half were going to have fatigue, headache. Some people had muscle aches. And the reality is that some people had fevers up to 103, up to 104, transient fevers that were resolved by rest, Tylenol, and or ibuprofen. Some people actually had diarrhea and vomiting. And so these were all known side effects of a new vaccine. I think it's also important because people ask us, and I may be preempting a question that comes later, will I get sicker if I've already had COVID before and gotten the vaccine? The anecdotal response to that initially was yes. There's actually some data that came out in a pre-publication in Journal Watch earlier this week that actually showed that about 30 to 40% of people that have actually had COVID had more symptoms. But the exciting thing, they actually have a higher immune response as well, right? So there's a conversation that we can get into later about if you've already had COVID, maybe you need 1 shot. That's not the conversation for today, but we can do a Q&A about that later. When I talk about vaccine side effects, done HIV for 20 years, in the early HIV years with Kaletra and Dansine and a host of things, people got immensely sick, right? And we just pre-medicated them. I think it's important for people to understand that and, hey, have Tylenol or ibuprofen on hand. And again, if you compare the shingles vaccine to the Pfizer vaccine to the flu vaccine, you can see across the board. Shingles is a worse vaccine in terms of side effects, and the flu is better. It always is interesting, though, that the placebo, which is essentially normal saline, is the equivalent of the flu vaccine. And that's people that essentially got water into their body. So not to say that patients are interesting, but patients are interesting. I'm going to pivot to Moderna. Again, I think the colors are flipped, but again, you can see that efficacy line. The blue is those that didn't get it. The red is those that did. And again, I'll let Dr. Morse talk about this since he specifically was involved in this.
Right. So one point before I even discuss this, one point I want to make is that I want people to know, and so I want to clarify my role in this in the vaccine development process. So before phase 1, phase 2, and phase 3 clinical trials are trials in which people are receiving the vaccine. My area is the preclinical studies. These are the animal studies. These are the studies in which you have animals that are getting the same injections, same challenge. And challenge, essentially, you get vaccinated and you get challenged with the virus. And so what happens is I want to stress this, there are so many levels of protection that are between you and the vaccine that you get in your arm. So once again, it goes back to that Operation Warp Speed name. People are like, this is rushed. Nobody's looked at this. There are so many layers of protection between you, no matter how fast or how much faster it went this time. There are many layers between you and you getting a shot. And so in the animal studies, when I saw this, so I was literally one of the first people to see how effective this vaccine was in the animal model. And I was at my microscope, I sat back and I was in shock and I had to go back and look multiple times because I couldn't believe it, how effective it was in neutralizing the virus. And so when I took this information back to the group, moving forward, phase 1, phase 2, phase 3, that's when everything matched up. So it was not surprising that it was 95% protective in the human trials, because we saw how well it worked in animal models. So there are many, many layers, but we don't talk about that. There are many, many layers in between what you get and what is started in the laboratory setting. So I want to make sure that that is clear. And so this line that you see on here shows that you have a nice separation between the placebo group and those that were administered the vaccine. And so that's what you want to see. You don't want to see those lines together. You want to see them bifurcate and separate and go one way and one go the other, and preferably the vaccine staying low along the x-axis.
Absolutely. Hey, Dr. Moore, people
Yep.
always ask, well, will the vaccines protect you from transmitting? I think it's one of those yet to be determined pieces, but the Moderna trial actually had some data that I'm showing on the screen. Can you speak to that?
Right. Yeah. So exactly. So, I mean, the whole point is that we have shown with this vaccine that replication in the nasal passages was decreased or minimal in people that received the vaccine versus though in some cases. So that's why they're telling you, even if still be very careful about wearing your mask, about being around people, because you could be protected from an antibody response systemically, but you still could have virus in your nasal passages and your upper respiratory tract, and you could potentially pass that virus along to people around you, but you not get sick. So these are important facts that people need to know. Some people say, hey, I get my vaccine, I can go out and go party now. That's not the case. First and foremost, if you do get one vaccine, it still takes 12 to 14 days for you to generate an immune response that is protective. And I know that Dr. Allozy later on is going to talk about protection versus one shot versus two shots, but you need to get that second shot. The second shot is what gives you that full protection, but still take those precautions in between that time frame.
Absolutely. And I think it's exciting to know that Moderna did this, and actually AstraZeneca released some information about transmission. And it also seems, although it's a different mechanism, to reduce transmission by about 2/3. So we'll have more of this information as the year goes by. First things first, though, people need to get their shot. And I think that's important. And so this is a graph that just sort of compares the two vaccines. These were the first two that we had, that the world really had. Pfizer versus Moderna. I think the biggest difference is in terms of cold storage, right? The Pfizer requires an ultra cold freezer as opposed to Moderna. Efficacy is the same. And so at the end of the day, it's really like the old Miller Lite battles, right? Is it taste great or is it less filling, right? And that's really what this is about. At the end of the day, they're both great vaccines. And I think it's important for people to sort of take that home. I'm going to briefly comment about some of the other vaccines that are not necessarily ready for prime time. There's an expectation that they will present their data to the FDA. Johnson & Johnson has actually prepared and has already given some prelim data to the FDA that'll go in this week, and then I think they're set for February 29th, if I'm not mistaken. The Novavax trial was in 2 phases. It was the UK trial. They had over 15,000 people, 18 to 84. Again, remember, all of these trials are essentially in 18 to 84, except for Pfizer, which is 16 to 84. The exciting thing about Novavax is, hey, it hit that bar of 50%. It went to 89.3%. But not just that, it's one of the vaccine trials that actually took part in South Africa, where they were having a large burden of transmission with the South African variant that we're getting concerned about, right? And so again, even then, it had 60% efficacy, and just as importantly, no hospitalizations and no deaths. We're going to have to start talking about that as a community, both as a lay community and a healthcare community, that the 95 top line, 89 top line, 72 that you're going to hear CNN and Fox and everybody else talk about is nice, but that is may not be the actual issue. And so again, just kind of food for thought. When we mentioned Johnson and Johnson, many of you heard the Johnson and Johnson piece, and it was unfortunate. And I was actually really disappointed in the press that what they led with was 62% and 72%. Absolutely, that was the efficacy of the trial. Both the United States had the top line at 72, other areas, I think Brazil had 52. But I think what's really important, again, is 85% effective with severe disease, 100% effective at hospitalization and death. Also worked in South Africa. They had a raging pandemic and spread with the South African variant. And very important, especially for various parts of this country, when we talk about our supply chain, one shot. Not just one shot, normal refrigerator. So an organization or a community doesn't have to go and drop 20 grand on an ultra cold freezer. They can use the equipment they have. They can ensure, because you're on average going to have a drop off of 10 to 20% on the second shot. We're already seeing that in hospitals across Texas, for sure, in other parts of the country, that some people are not coming back. And so the totality of this conversation is going to be very important to how we ration and get supply out. I think the key thing is, let's get vaccine out. Let's get supply, because we're not going to have enough the way it is right now. And I'll mention AstraZeneca really briefly. Again, if you took anything away from the Moderna and the Pfizer, you realize that those lines were very different than this line. Those lines were wide open. These lines are a little bit closer, right? And there's a host of issues that AstraZeneca has had, specifically because of a manufacturing issue. They gave half a dose, and it seemed as if the half dose actually worked more than the full dose. There seems to be actually some further analysis showing that it may not have been the half dose, but the fact that they took longer to give the second dose. And again, conversations that FDA and regulators and physicians will figure out over time. But looking at them side by side, sort of bluff, bottom line up front, you can see some of the differences. mRNA versus simian adenovirus. I hate the fact that they say it's chimpanzee. It's another of those Operation Warp Speed language things.
Right.
People are not going to want to take a chimpanzee thing, but if it's simian, sounds a lot cooler. Just kind of food for thought. I think the efficacy of mRNA versus AstraZeneca at 62%. Again, that low dose group was 90%. And then there's just a couple of other things going on with it. And so they're going to submit data to the FDA, but they have to clean some of these things up before we get there. And so I think that's important. Again, I apologize for the quality of this. I took this from a colleague, Monica Gandhi at UCSF, did a great job of really outlining all the different vaccines that exist right now: Moderna, Pfizer, AstraZeneca, J&J, Novavax, and the Russian Sputnik, who actually released data in print this week. But I think the important thing here that I call out is, it's amazing that we're here with potentially 6 vaccine candidates with a range of efficacy, and most likely it'll be a range of who gets it for various reasons, and we'll start to be able to tailor these vaccines. And I think that's immensely important. And if you're just one of those people that wants the bottom line numbers, these are the bottom line numbers for the ones that may come to the United States market. Overall efficacy for Pfizer and Moderna, approximately 95%. However, no data in South Africa. And if we're talking about South African and UK strains that may become the predominant strain in the United States over the spring and summer, that's going to need to be a question. And so again, Ian's group and other groups are already looking at boosters, and we can talk about that a little bit at the end. But I think that's really where I'm going to end that as we go to the next stage. Dr. Moore, any thoughts?
Yeah, I think you're covering it, man. I want to tell everybody who's watching this, you probably won't get a presentation this clear and statistically solid anywhere else. And I have been working with this vaccine since, like I said, since February, and there are a number of people who are experts in the field. I'm going to tell you right now, Dr. Allozy is laying this out for you like a red carpet. All you have to do is walk the walk and get to the other end and get your vaccine. So I want to give you a big, applause in the middle of this presentation, because this is extremely solid, well planned, well put together. So I appreciate it. Yeah, absolutely.
Thanks, man.
Mhm.
All right, I'm going to pivot to distribution, and we're going to talk about some hurdles ahead. I'm not going to belabor the distribution, but I think it's important for people to understand this is not a United States of America problem. This is a global problem. There are billions of people on this planet, 7 to 8 billion, depending on whose numbers you want to take. And you can see already when you talk about the governments that are trying to secure vaccine, India has 1.6 billion. The European Union has 1.4 billion. The United States has 1.01 billion. It's called a billion. And remember, all of those are secured vaccine that you have to cut in half to get the number of people that it will affect, right? So these are secured 500,000 people. The problem is we put most of our eggs in the AstraZeneca basket. Understandable from a policy standpoint because they had some of the earliest data earlier this summer. Right? However, it's still not available to the United States. And so between Moderna, which has actually been upped to about 250 million now, and then the Pfizer at 100 million, that only gets us to 150 to 160 million people potentially vaccinated. And so those are some of the concerns, and those are some of the key reasons that we're going to need Johnson & Johnson. We're going to need AstraZeneca. We're going to need Novavax to really get vaccination across the board. You may have heard, and hopefully you've seen this, what the rollout is supposed to look like, the so-called 1A, B, C, and phase 2. I think it's important to really understand that this was controversial, but I think it's based on risk. And so healthcare workers were put up front, but not just healthcare workers, but the people that had the largest burden of disease in the United States, persons living in long-term care facilities, nursing homes, and such, right? We're still struggling with that. But to get vaccine in arms, a lot of organizations, a lot of states, Texas is one, has said, hey, we're going to continue to focus on our healthcare workers, but we're also going to give 18 to 65 if they have two comorbid conditions, right? And so different states will be allowed to do different things. I think the important thing is to get vaccine in arm. I'm going to share something, and we're going to use you, Miss Johnson. I know you're writing questions because I can see them on my peripheral vision coming in faster, furious. So I'm going to assume, Miss Johnson, that you're 40. Let's say you're 40. What county do you live in?
I am proud to be 45, sir. And I live in Fort Bend County in Texas.
All right, Fort
I thought
Bend.
I thought you were 35.
I think I'm 25. If my brother on the line, he gonna say, "What are you talking about? You're only 25."
I didn't want to go down that trap. So all right. So you're not a healthcare worker. And the other things, COVID-related risk factors, I will assume no. I'm going to hit submit. And you can see, and New York Times did a great job of this. You are down. Whoa, you're way down. You're all the way down here. Right. And so, but this is a reasonable assessment of how many people are trying to get this vaccine. It says it right here. When it comes to Texas, you're behind 24.4 million people who are at a higher risk. And in Fort Bend, you're behind approximately 500,000 people. And so when people say, why can't we do better? Why can't we do more? The reality is we're resource constrained. We don't have enough vaccine. And there's millions of people who, if they get COVID, can die. Right. And so, again, you've heard the politics about people that have access, people that have money, getting access to these vaccines. I think there's a different conversation about equity, and it's disappointing that we potentially failed again and how we are attribute equity and equality in healthcare. But that's a longer conversation for another day that I can't fix today. When we sort of think about concerns, I'm a Douglas Adams guy, and so it's life, the universe, and everything. I will say this. In 2020, we did 4 big things that required really complex communication skills, right? Required communication, trust, and logistics. We essentially screwed up on 3 of them. We screwed up masks. We didn't get the mask conversation out on time. We screwed up PPE because we didn't believe that PPE was important. And I truly believe we should have used the Defense Production Act to get it out there faster. And we screwed up on testing. We wasted months and months trying to figure out whether we should test, who's testing, is it too much, positivity rate, all these things that if we had just gotten the damn tests into people's hands, we could have protected some of our most vulnerable, right? But you can understand, however, why there's lack of trust. And we need to rebuild trust in the medical system, right? Because people still do trust the people that are in the healthcare community to give them the right numbers. Oops, sorry, I missed one. And so what we need to do, and it's interesting, what we probably did well, irrespective of what side of the political line you stand on, was voting. We had more people vote than ever in the history of this country. It doesn't matter who won. The fact is that we got that right. And we need to use that same vigor and communication and empathy around getting people vaccine. And again, part of the problem is this, right? And you can read the cartoon and I'll voice it over, but you hear it all the time. Today, we're going to discuss a controversial topic. Caller one, you're here to give the facts on the topic, but display no emotions. That would be Dr. Moore. Yes, I'll be reasonable. Caller two, you're here to argue with caller one emotionally, but give no real facts. Buckle in for some mad rants. And who's the winner in this? It's the press, right? The cartoon on the other side. Next up, we'll discuss the topic with someone whose job is to be a well-researched and respected expert in the area. And in the interest of balance, we'll also talk to an idiot. I feel like that all the time for the amount of time that I have spent in media rooms and all these other conversations. And I understand reasonable people can disagree, but there are some things that people disagree upon that are not reasonable. And we got to call a spade a spade. We got to call a lie. And we have to tell people when science drives a decision. And science doesn't drive every decision, right? So I think that's also important for people to understand. You can then realize, and this is back in September, why there's so much hesitancy, why there's so much vaccine hesitancy. You look at the communities of color, right? Hispanic, Black. This was back in September. The Kaiser Foundation did a more recent one about a month ago, and you can still see that about 27%, this middle blue line, is still hesitant to take this vaccine, with African Americans being around 35%. The good thing is that since this rollout, it's actually started to trend better, right? So I think that's immensely important. People like Dr. Moore, others in this space that have continued to give that messaging out, YWC and other organizations, spoke with the Baptist Health community in Nebraska some months ago, all focused on giving out this information, because if we fail our communities of color, we're already predominantly affected by this. It only gets worse, from school to economics to a whole host of things. I think that's important. One of the things that people ask all the time when they talk.
Dr. Lozzi.
Yes, ma'am.
Okay. After this, can you ask Ian to compound, like tell his history and where he graduated from and why there may be a little bit more of hesitation with the Black community and communities of color to want to.
Right now, Dr. Moore, go for it.
Yeah, go ahead.
Oh, you're on mute.
Sorry. All right. Sorry about that. Yep. Can you hear me?
Yes, sir.
All right. Yeah. No, I will actually. This probably is a good time to talk about it. If you can go back one slide, Dr. Lozzi.
Right there.
Yep. There you go. So notice that 53%. That in general, if you look at by gender at the top, these are people who are extremely or very likely to take it. And then you have the groups who are not likely to take it. And so if you look at the group of in Black and Hispanic and white, 37% of Black people right now, based on this chart, are not likely to get it. And so I think that in itself, I mean, I definitely want us to get to that and talk about that. But for me, I grew up in Alabama in a rural area. I went to Tuskegee University. And so I was actually at Tuskegee during the time in which they established the Bioethics Center. That's when Bill Clinton made the public apology for the syphilis experiment at Tuskegee. And so I have a very special understanding of this process because I was there. And as a student at Tuskegee, you learn certain things about the campus. When you first get there, you read Up From Slavery. That's a book that you have to read as a requirement as a Tuskegee student. But as also being there, you learn about the history of the campus, you learn about the school. And that was one of the uglier aspects of how the country took advantage of these Black men in this community, essentially allowing them to go untreated with syphilis and then go back and spread it in the community. And it was called the natural progression of syphilis in the Negro man. And so that is, that's a really bad stain. But with that being said, I want everybody on this call to recognize the fact that that was a different time. It's a good lesson, but it is very much a different time because there are people that look like me. As a matter of fact, if you are not familiar with it, one of the lead scientists in the development of this vaccine, Dr. Kizzmekia Corbett, 34-year-old brilliant Black woman, is the person who's at the top of the chain leading this effort. I speak to her on a weekly basis, and we talk about this. But then I'm able to watch it at the preclinical level. So there's a difference in this vaccine. So there's, people have conspiracy theories, but there's no nefarious. Nobody's trying their best to poison people or get rid of people and all that kind of stuff. And just to be completely honest, I've heard a lot of conspiracy theories. I've heard people say, well, they're just trying to get rid of Black folks. They're trying to, there are lots of thoughts, but if there were a need or a desire to, it wouldn't be vaccines. There'd probably be blood pressure medications or diabetes medications, because those are the things that we sometimes are most afflicted by. So don't let somebody try to dissuade you from taking this vaccine. This vaccine is going to protect you and keep you safe. And so I do want to make sure that people understand that. I want to make people understand that we are a part of the team now. We are part of the team. We are at the table, and we are making sure that it's safe, not just for you, but for everybody. And so we want you to have confidence when you go and take these vaccines. But I don't want to harp on that too much. So I'm losing focus here. So I'm sorry. So I'm going to go ahead and give it back to Dr. Alozie. But that is the point, though. So don't focus on the facts of the vaccine, and know that we are in the chain of the process. And so there's nothing from that perspective that another Tuskegee experiment is not going to happen, because we are here and we are involved, and we care about us as much as we care about anybody else.
Absolutely. I think that's a critical piece, right? You can't have a conversation about us without us. And people like you and others are now in the process. They're at the table. And so I think that is a huge difference from the Tuskegee era to now. So I appreciate that, Dr. Moore. That's immense. I'm going to speed past because I know I'm already going over time. But I think one of the things about side effects that people have asked is, well, what happens when I've had a severe reaction before? I think, again, that's a conversation to have with your physician or your clinician. That was part of the exclusion criteria in the trials. History of severe adverse reaction associated with the vaccine. And again, like Dr. Moore mentioned, a lot of this is about the language and how do you communicate with people, right? Again, we failed several times in 2020 on communication. And I put this out there because it's funny more than anything else, but I assure you this, if we knew that COVID could cause erectile dysfunction, there's so many people that would have worn a mask early. There's so many people that would have gone to get this damn vaccine without any conversation, right? Because it would have been driven by men who are predominantly policymakers, and fortunately or unfortunately, depending on which side you're on, rule the budgets of these things. Again, tongue in cheek, it's kind of funny, but I think it's just out there. One of the last sort of pieces I round up is that reminder, and sort of buttressing what Dr. Moore said around, because you get the vaccine doesn't mean it's time to go buck wild, right? There's a host of things that we have done and failed to do in the process of this pandemic, from staying at home, wearing masks, hand hygiene, avoid touching your face, if in a crowd, limit the time, and then the government, society, companies sort of failed to do other things. Testing and tracing, that didn't work very well. Ventilation in older buildings, especially in some of our schools, concerning. The financial support that people need, if they're going to be told to stay at home, they can't stay at home and pay their bills with water. And so they need that support, right? Quarantine and isolation. Where do you quarantine and where do you go? I've done some work in the Navajo Nation, and it was amazing to me how in those homes, and in multiple homes across the country, especially in the South, when you have multi-generational homes with a child, teenager, adult, and an elderly person all in the same household, how do you quarantine? How do you quarantine in 1,500 square feet when all those people are in the same place? Vaccines is that sort of last piece of the Swiss cheese model that will hopefully allow us to get to, as Ms. Johnson said in the beginning, back to whatever normal is going to be. And we can talk about normal. But it's important to people remember Those four keys that Atul Gawande talked about early on in this pandemic, wash your hands, watch your symptoms, wear a mask, and watch your distance, are still going to become critical. We still need to, however, and I'm really adamant about this going forward, we still have to give people that conversation around hope. We can't tell people to go get a vaccine if everything's going to be the same way it was for the rest of their lives. That doesn't provide hope. The vaccine has to be this pathway out. The vaccine has to also remind them that, hey, yes, you can, like me, get COVID and survive. You can have a long list of other symptoms that could affect you for months and years to come. I still can be sitting and I'll look at my watch and I'll be like, oh, wow, 130. I'm not doing anything. Yep, 130 about an hour ago, doing absolutely nothing, right? So you don't want to get COVID. That's not the pathway out that we want to take, and vaccines provide that hope. And so those shots in the arm are critically important. We haven't talked about this specifically, but I'll jump to it because herd immunity is really what vaccines are supposed to do. And so this is why it's so important for policymakers and healthcare workers and healthcare decision makers and people to understand why vaccines are important. You can see this slide right here, and it says, if we were to give 1.5 million people vaccine a day to get to 80% immunity, it would take to December 24th. Right? That's why they're trying to get more and more. It changes if we get this to, let's say, 70%. But only to November 10th. If you really want to make a change, and this is where some controversy is going to come in policies over the next few months, is do you go to one shot that gets us to July 2nd, right? Or do you vaccinate people like me that have already gotten vaccine, shortens it by a month? But the key decider in these variables is one shot versus two. And so that data that's come out recently about people who have already been infected having up to 10 times as much immunity may start to play into policymakers. And so again, conversations for future, but I think it's important to understand where we're going with this. And so this is an arms race to get as many shots into people as possible. We want to be vaccinated. We don't know if there'll be a vaccine passport or not. My guess is at some point, various organizations and locations may say, hey, you don't get to come into my restaurant if you're not vaccinated. You don't get to come on this plane if you're not vaccinated. You don't get to go watch Usher in Vegas if you're not vaccinated, and it'll be tracked somehow by your phone. And so I think all those are very important things. Again, to close, another sort of summary of all the things that are going on. Again, not to belabor this, I'll send it off. I will say two more things in closing. May we never again take for granted Friday nights with friends, those birthday celebrations, the roar of a stadium, mornings at the gym, a packed dance floor, coffee with a friend, crowded Usher concerts, happy hour, or life itself. Amen. And just as importantly, nothing should go back to normal. Normal wasn't working. If we go back to the way things were, we would have lost the lesson. May we rise up and do better to be better. 2020 was all about masking. 2021 should be about masking and vaccinations. Dr. Moore, I'll let you take it home.
All right. I want to just, say thank you for that. I want to make an absolute, use this last few minutes to make an absolute plea to the people who are watching this presentation. People have a lot of, people risk a lot of things. Risk is every day. Every day you walk out the house is a risk. If you were at my house right now and you're getting ready to go home, I would say, hey, give me a call when you get home. I say that because I know that something could potentially happen when you leave the house. If it's raining outside, I say, hey, you want my umbrella or you need a jacket? Because it's raining, you need to protect yourself from getting wet. This vaccine is no different. I know that's a very simplistic explanation, but this vaccine is no different. The question is, there's vaccine hesitancy. Are you hesitant because you think the vaccine will hurt you? If you are, then the question is, which one do you want to bank on more? A virus that is literally filling up morgues? Or do you want to risk a potential side effect, a mild side effect that has been reported? Because once again, people are saying, I want to wait and see what happens to other people. That's where the clinical trials come in. So that has been assessed. We've with this vaccine in particular, with the Moderna vaccine, 15,000 people were given this vaccine. And those 15,000 people are still going. None of those people have had any severe, any issues. And so that's kind of the point. So do you want to gamble on how, because the other part of it is that getting infected, there are people who have mild disease. There are people who are on ventilators. You don't want to gamble and find out where you fall in that spectrum of disease, especially if you have a pre-existing condition. So with that being said, I received the vaccine. So I'm not one of those people saying, hey, because I've had that question, hey, go get a vaccine, go get a vaccine, get a vaccine. And the question is, well, have you been vaccinated? I sure have. I've been vaccinated. My wife has been vaccinated. And let me, I know you don't know it, but I talked to my mom into getting a vaccine. If I had my mom get a vaccine, anybody can get a vaccine. My mom, she wasn't scared. She just doesn't like vaccines, period. But she knew. I explained to her. I said the benefits of protection versus the risk of severe disease. You don't want to risk those things. And so for the people who are hearing this message, you absolutely need to go forward, get your vaccine. And at this point now, it's kind of hard to even get vaccine because there is such a shortage now because certain states are not getting as much as they were supposed to get in the first place. So don't wait. If you get an opportunity, I would have taken Pfizer. I would have taken any of those vaccines that are approved. I just took the Moderna vaccine because it was offered to us as an NIH employee. So I took it. But if I hadn't had to get the Pfizer vaccine, you better believe I would have taken it. So I want people to understand that. I'm not on a soapbox just talking down. I took the vaccine myself. I experienced soreness. That's it. My second dose is coming this week, actually. So for those people who are listening, get your vaccine. It is safe. It is effective. Protect yourself from unnecessary hurt, harm, and danger. And with that, I'm gonna let Dr. Elozy do the benediction.
I appreciate it, man.
No, we won't be done unless you guys.
No. Okay. Sorry.
I would also like
he was tongue-in-cheeking it.
Yeah, Dr. Elozy, can you share your experience with being COVID positive?
Yeah, COVID sucks. Here's the thing. I thank God that I did not end up, as I sort of like to call it, upside down, on a ventilator in an ICU somewhere. I think that COVID is just something you want to avoid, right? I felt fatigued. I was generally good up until the time I found out. And actually, I took what's called the monoclonal antibody infusion because I'd gotten kind of fluffy in 2020. And so I actually met the BMI criteria. And so the antibody infusion made me sicker than the actual virus. I had a headache for 5 weeks, one of the worst headaches of my life. And so I can't get vaccinated for at least 90 days until that antibody sort of wears out of my system, so it doesn't blunt my immune response. But as you know, Ms. Johnson, I've been a proponent of the vaccine in my community and communities of color everywhere I go, doing some work in Nigeria soon as well. And so, this is not local, national, countrywide. It's an international issue, and each of us in our various communities, and I overlap in multiple communities, being born in Nigeria but grew up in Minnesota. I'm gonna fight and push and prod and cajole and threaten people to get the vaccine as much as possible, and they can at me as much as they can. Well, that's the only way that we're going to get back to any semblance of normalcy.